Welcome, fellow physicists, and we take an exploration through the land of physics. This place is home to many great discoveries like gravity, space-time, quantum mechanics, and much more. So, without further ado, let's get into mountain mechanics, the first destination of this tour. Here, we investigate Newton's laws of motion, relating when he was still a young, carefree man, investigating gravity and more. Here resides one of the most beautiful equations of all time, which is known as the universal law of gravitation. It states the relation between two masses and the gravity between them, a great breakthrough in physics at that time. As for the next place, we enter a simulation made by none other than J.C. Ampere in 1834. This was solely and only used to investigate kinematics, which did not involve mass but instead time, displacement, integrals, velocity, accelerations, derivatives, and a whole lot of change, which was another thing that Newton made. But before that, let's get into the lavas of Thermal Mountain, where a young physicist from France named Sadi Carnot investigated thermodynamics. His father, a general of Napoleon, went off to war while he studied this amazing field of physics about heat, the change of temperature, and even entropy, one of the most central part of modern physics. He may have been one of the greatest physicists of all time. But next, the limitless creator of calculus. Here, Isaac Newton and Fermat had a war. Isaac Newton using integrals and derivatives. Fermat uses maximum points and functions. They fought on, with Isaac Newton winning and leaving this crater as the memory of partial derivatives, integrals, and change. Following on, let's explore the mines of magnetism, discovered by none other than Gauss, Faraday, Ampere, and much more, but unified by Maxwell. As for his laws, we shall get into that sometime later, after a brief tour and understanding of this world of wonder. Where will it take us next? Only time will reveal the path of none other than the thing we use most. Aside of sound, light, and photons. For this example, this photon is sending a message, an invitation to the quantum island, to a physicist so renowned and so special that he won a Nobel Prize, which is nothing much compared to some other accomplishments, but still cool. And this is Erwin Schrödinger. Furthermore, let's explore the island where the light photon takes him. On the shore is where Euclid and a few others investigated light and reflection. And here on the ocean lays two central concepts all about waves, sound and light. Sound on the dark border was invented by Galileo Galilei, and light by Thomas Young with his famous double slit experiment, which then revolutionized physics, and also the wonders of quantum mechanics, which is what is here on this forsaken island. Sadly, no one can get inside without an invitation. So I guess there will be something we explore some other time, but a quick brief into it. Quantum mechanics concerns gluons, quarks, muons, a jumble of electromagnetism, and much more. And now, time to explore something you guys would probably know from, I don't know, E equals mc squared, general relativity, the darkness discovered by Albert Einstein in 1950. This is your final chance to turn back before our plunge into darkness and dangers of the space-time graph that we and the universe resides on. The first danger, the black hole. Its gravitational pull so sure that time and space swap places. Its pull inevitable to all who goes near. You may not and will not be able to survive once the event horizon has been crossed. Not even the cute little messenger's light can get through. Next thing, the Big Bang, where the origin of the universe is said to be. Then it was just dust, plasma, and chaos. But now it gives one of our greatest stars, the sun. It is a central part of all physics, astronomy, and even biology, chemistry too. This nuclear fusion and entropy is really an amazement to all who witness it. Now, let's stop and get into the imaginary realm, stuck behind our imagination of square roots of negative numbers. Invented by Rene Descartes, he was fond of the idea or needed the idea of square roots of negative numbers, which leads to the final part, the shrine and altar of legends. People have worked hard trying to unify the four central part of physics, the ebony darkness, minds of magnetism, and quantum island, with imaginary numbers, calculus, and much more. Galileo, Newton, Einstein all tried and failed, and throughout the world, many physicists work on this theory. This theory is none other than the grand unified field theory. Who knows? This world of physics keeps changing faster than the derivative of a slope, and maybe you shall be the person who explores and ventures through the darkness of this land. And until now, that's the end of the tour. Witness the might of physics and mathematics.